Hello, today in this tutorial we are going to see how we can check the Spring AI chat client metrics or how we can get the information about the prompts that we are sending to the LLM and the response that we receive from the LLM. So when we say the chat client metrics, it includes some of the important information like how many calls we made to the LLM and how many were successful, how many were failed, the token count usage, which includes the input token as well as the output token. So all such useful information we can get it from the chat client metrics. So before we jump into the metrics part, let's quickly understand the application that we will build. Post that, we will make the request to our application and observe the important metrics. So when it comes to the sample application, here we are building the AI powered customer support assistant, wherein the user can submit the support queries, and based on the support query our assistant will simply send back the response. So it is a very simple application with one endpoint wherein user can submit their queries and we will receive the response from the LLM. So when it comes to the project structure, the name of the project is Spring AI Chat Client Observability Matrix. It has the one controller class, one service class. We have two set of DTOs, one for accepting the request from the user and one for sending back the response to the user. Then we have the Spring Boot main class, and then we have the application.yml containing configuration related to the LLMs as well as the metrics, and then we have the pom.xml containing the project configuration. Now coming to the IntelliJ, here you will see the project structure is exactly similar to what we have just seen now on the blog. We have the controller which will accept the request from the user, which and then controller will forward it to the service class will interact with the LLM, and once we receive the response from the LLM, service class will return it to the controller and controller will return the response back to the user. Now let's understand what we have inside the pom.xml. Here we are making use of Java version 21 and the Spring AI version that we are making use of is 1.0.0, which is the stable version. In order to create the REST APIs, we have added Spring Boot Starter Web dependency, and then we have added the dependency for OpenAI, which is starter model OpenAI. So even though we have added a dependency for OpenAI, behind the scenes we will configure our application to interact with the free model which is available on the Open Router platform. And inside the dependency management section, we have added the Spring AI bomb dependency, which is useful for managing the Spring AI related dependencies. Now in order to get the metrics, so here we have added the Spring Boot Starter Actuator endpoint, which will export certain useful endpoints using which we will get the required data related to the LLM interactions. Now coming to the application YML, here we have specified the configuration which is required for interacting with the LLM. First, we have specified the API key which is required for interacting with LLM. Here we are passing it via the environment variable, and since we will be interacting with the open router, for which we have configured the open router base path, and the model that we will be interacting with is the Cypher Alpha, which is the free model available on the open router platform. Now earlier we added the Spring Boot Actuator dependency. In order to enable the Spring Boot Actuator matrix endpoint, here we have added the configuration which is management endpoints web exposure include. Here we have specified the value as star, which means it will simply expose all the endpoints that are present inside the actuator. In your production environment, you can specify the specific endpoints that you want to expose. Also, you can secure endpoints using the Spring Security. Now, in order to enable the prompt logging or AI response logging, here we have added certain set of configuration. So first, inside the AI chat client, we have added one configuration which is log prompt equals to true. It will log the prompts that we are sending to the LLM. This also includes the system prompts as well as the user prompts. Now in order to log the response that we have received from LLM, we need to add this configuration which is log completion equals to true. And if we want to log the errors that we are receiving from LLM, we can simply add this configuration which is include error logging with value as true. Now coming to the controller class, it is a very simple controller with just one single endpoint. The base path for our controller is /API/chat, and we have created one post type of endpoint with path suffix message. Whenever user has to submit any technical query, they will simply call this endpoint by specifying their query. So the user input is mapped inside this particular Java record, which is chat request, and the query that user has specified will be mapped inside this particular field, which is message. Now once we have received the input request, controller will simply forward it to the service class, and service class will interact with the LLM, and whatever response that we have received from the LLM will be present in this particular form, which is chat response. So inside this chat response, we have one simple field response containing the resolution or the response that we receive from the LLM. Once we have received the response from the service class, we are simply returning back to the user. Now coming to the service class, at the very top we have defined the system prompt for our LLM. So if you see the system prompt content, it simply says you are a helpful customer support assistant. Based on the query that user has submitted, simply resolve that. So we have defined the system prompt, and then we have specified the chat client, which is useful for interacting with the LLM. So this chat client is getting initialized inside the constructor, for which we are making use of chat client builder, which is provided by Spring AI. So here you will see we are simply calling chat client builder.build, which will simply initialize our chat client. Then we have the process message method, which was getting called from controller. Here we are receiving the user request, and based on which we are calling the LLM with the help of chat client. So here you will see chat client. We have specified the system prompt. We have specified the query that was received from the user. It was present inside the message field. Then we are calling the LLM, and once we have received the response from the LLM, we are just extracting the main content or the main response that we receive from the LLM. We are simply ignoring the other metadata which is present. So once we receive the response, we will simply return it back to the controller. And during the whole process, if any error is encountered, we are simply drafting one simple error message which will be returned back to the user. So this was the simple overview regarding our application. Now let's try to run this application and see the metrics related data as well. So our application is started. Now we are calling the API chat message endpoint, and we have specified the query that user is facing issue while paying for an order. Now when we send the request, behind the scenes the request will go to the open router platform, and it will be handled by the free model that we have configured, which is Cypher Alpha. So now we have received the response from our smart AI assistant related to the issue that user was facing. Now coming to our application, here inside the application logs, you will see we have the content observation handler, which is printing the prompt that was sent to the LLM. So here you will see the system prompt is mentioned, which we have seen just now, and then the query that was submitted by the user is also present inside the user prompt field, which is I am facing an issue while paying for an order. And in order to see the response that we got from LLM, here you will see we have chat model completion observation handler, which is printing the response that was received from the LLM, and this is the same response that we are getting inside the Postman. So this was regarding the prompt logging and the AI response logging. Now coming to the metrics part. So in order to see what all metrics that are exposed by the Spring Boot Actuator endpoint, we have the Actuator metrics endpoint. When we will send the request to this endpoint, here you will see certain metrics that are present specifically to the AI, for example Gen AI client token usage, and then we have certain set of metrics present related to the Spring AI as well. Now coming to the first matrix, which is the HTTP client request matrix. Now we are making use of Spring AI to interact with the LLM, but behind the scene, Spring AI is basically making the REST call to the AI models. In our case, we are making the REST call to the AI model which is available on the open router platform. Now when we will send the request to HTTP client request endpoint, this will simply display the data related to the REST call that our application is making to the external world. Now when we will send this request, here you will see the number of requests that were made by our application is 1, since we have just sent one message to the open router platform, so the count is 1. And here you will see behind the scenes the call was done to the openrouter.ai, and the endpoint which was called was API v1 chat completion, and the result of this call was 200 OK success, and no errors were observed, due to which the values are mentioned as none inside the exception as well as the errors. So coming to the next endpoint, which is Gen AI client token usage. Now when we will make the calls to the LLM, behind the scenes tokens are getting used for input as well as the output. Now in order to see how many tokens were actually used, we can get the metrics with the help of this endpoint, which is Gen AI actuator metrics Gen AI client token usage. Now here you will see the count is the total number of tokens that were used are mentioned here, and this is related to the open router Sapphire Alpha model. And if we are interested in the breakdown of this token, we can also specify the filters, like we want to check the number of tokens that were used for input, or the number of tokens that were used for the output, or how many total tokens were used. We can get this information. Now let's try to see the information related to the number of input tokens that were used. So all we have to do is we can specify the filter with the help of like tag equals to Gen AI token type equals to input. This is nothing but the tag name, which is Gen AI token type, and based on what value you want to filter your metric. So here we are interested in input, so we have specified the value as input. So here you will see the number of input tokens that were used were 465, and if we have to cross check this, we can go to the open router platform, within which we have this activity page. Now when I will refresh this page, here you will see one call was made to the Sapphire Alpha model, and the total number of input tokens that were used are 465. And if we check the number of output tokens that were used, here you will see the number of output tokens that were used were 195, and same are mentioned on the open router platform. So this is how you can track the individual token count if you are interested. Coming to the third endpoint, which is related to Spring AI chat client. So when we will send the request to this particular endpoint, you will see the total number of calls that Spring AI made were only 1, and the total time it took were around 6 seconds. The call was made using chat client, and since the call was successful and there were no errors, so the values is mentioned as none. And if there were any errors or any kind of exception is observed, it will be present inside this particular tag. So this was regarding the successful call. Now if you want to check how many successful calls were made by the chat client, and while making the calls to the LLMs, were there any errors, so how many such calls were there, so you can filter out based on this particular tag, which is error. So let's say we want to track the number of successful calls. So what we can do, we will make use of this tag error and specify the value as none, which will denote the number of successful calls. So here you will see we are calling the same endpoint, which is Spring AI chat client. We are making use of tag, and we have specified the error with value as none, which will give us the number of successful calls. In our case it is 1, since there were no errors. Now let's try to deliberately introduce an error and see how we can get the failure count. So here I am adding the invalid API key for open router platform, which will simply return an error when we will try to make the LLM call. So our application is started. When we make the request to the our application, the open router will simply return an error 401, since our credentials are invalid. And now if we try to check the metrics for Spring AI chat client, Here you will see inside the error, the value is mentioned as non-transient AI exception, which is returned by Spring AI. Now if we get, now if you have to check the number of error or number of error calls, we can simply specify the value with the exception that we are interested in. So now you will see the number of failure calls are 1, since we have specified the invalid API key. So now inside the application YML, we have added one additional configuration as well, which is include error logging. So while interacting with the LLMs, if there are any errors like errors related to rate limit or and so on, those will also be logged inside our application logs. So this was all regarding the Spring AI chat client metrics as well as the prompt logging and AI response logging. So we have written the detailed article for the same, which you can go through, and also we have created one detailed diagram within which we have specified the sequence, what actually happens when you submit the request to the application, and behind the scenes how the metrics and logs are getting recorded. So the sequence is mentioned here. And similarly, the example that we discussed during this tutorial is also uploaded on GitHub. You can check out and try the same if you are interested. Yeah, so that was all from my end. I hope you found it useful.